Avaya. The conference is now starting. You are the first person to arrive. You will now be placed into the conference.
Hi, James. Nice seeing you connected.
Hi. Yep. Nice seeing you connected too.
Oh, thank you. It was nice to have a conversation with you by email. We can continue.
Absolutely. I apologize for not answering the other email you sent regarding the research stuff, but I'll answer tonight. I just have not really had much time to.
Oh, do not worry, do not worry. I'm late in answering emails myself all the time.
Okay.
That's fine. Do you have camera? It's not that I'm dying to see everyone's faces, but when presenting, it's easier to follow a presentation when one does see the presenter.
Yeah, I actually only have a document camera. I don't have an actual camera, unfortunately.
Okay.
Yeah.
Okay, that's not a problem. And I will arrange a room for connection so that those of us who may come onto campus into a equipped room that is with all facilities, as we did in. Okay.
Yep, that all sounds good. The presentation's looking, by the way.
Oh, it's great. It's great. I'm very happy that you were able to prepare it in quick time.
Thank you.
Hi, Evan. Happy to thank you for supporting the event by connecting. Let's wait until. I know that Kristen sent an email that she will join us a little bit later because of her. So she needs to attend synthetic experiment, and I may send a reminder. Slides. And a special thank you to you, Janice, for connecting ahead of time. So at least the first speaker is available immediately. This is good.
Okay. Yeah, no problem. I always join early, so just trying to make sure.
Oh, you! Nice to see you. To see you connected. So your presentation is number 4. So when it will be time to present, if you have camera, it's preferred if you switch it on.
Okay.
When listening to others, it's not necessary, but while speaking, it's easier to follow when one does see the image of the head. Oh,
Okay.
hello, Joyanta. Thank
Hi.
you for. Oh, okay. Now you have microphone and camera. Everything works for you. I'm happy to see it.
Yeah, thanks.
Very good, very good. And thank you for making slides. I was worrying. You are my hero. You started much later than everyone else, and you were able to prepare it. It's great. Thank you.
Yeah, thanks. Yeah, you are welcome. Yeah, thanks.
Okay, so we do have speakers number 1, number 3, and number 4. Speaker number 5 will join, and we are it would be great if we see Mahima has connected. Hello, Mahima. Thank you for nice seeing you connected. So I think we will start in a minute. Those who are the speakers, those who speak. Oh, hello, Javed. Nice seeing you connected. Hello. So if it is your turn to speak, please consider to switch on the camera. When you're not speaking, it's your choice, but when you're speaking, it's so much easier, especially if connection becomes poor, but some people can read what is being spoken by lips. So it will be much easier to perceive, and one can show by hands when it is something important. Okay. Oh, Mahima did disappear. Oh, no. Here. So I will start with brief introductory word, and we have this connection reserved for a couple of hours, but I think we will finish within an hour, quite quick. So we are in the computational chemistry course, which there are some books, and the goal of the course is to provide theoretical background and get some practical skills to be able to predict results of experiments and compare and communicate with peers and colleagues. So today we are looking on the mid row in the first box, build molecular models, because without molecular models, all other activities are not possible. In the organization of the course, we are finishing the first chapter. So it's meeting number 8, and each meeting consists of lecture, background material, and practical skills. And today, the attendees of the course share the accumulated practical skills to each other. So by finishing today's meeting, we will be 25% completed with the course. And here is the agenda. We have 5 speakers starting from Linux environment and connecting to clusters, submitting jobs, transferring files. Then the second speaker, Mahima Murali, will show how to build models and modify parameters of molecular models with gaussview software. Then JoyantaBanerjee will explain how to clean and optimize geometry. Then Dr. Zheng will show an important part of building molecular models without building molecular models. She will tell how to import pre-built models of crystals from databases. And then the speaker number 5, Kristen L in Patnode, will show an example how to convert molecular models between different formats and what to do if the connection is slow and poor and you cannot connect to a cluster, how to modify models on a local computer with free software. So with this, I would like to invite to the stage the first speaker, JeniseAmb, and I suggest that I will just flip the slides, if you do not mind, and you just present and tell when one needs to go to the next slide. If you have
Okay.
different. Okay. Yep. I think if you just save time on sharing and not sharing display. Okay, floor is yours.
Alrighty. So this presentation is for our little meeting here called Physical Chemistry in 30 minutes. I will be talking on remote connections, CCAST accounts, job submissions, and originally I was going to do Gauss view, but that changed fairly quickly. So next slide. So first I'll be talking about Linux environment and different types of remote connections. Go to next slide. So firstly, we have a telnet remote connection. This is a unsecure method of remote connection, but this is typically used for networking and other forms of connections that don't require as much security protocols as SSH would. Mostly they're used for, connections that have not been set up for SSH yet. And that's a general theme throughout most of, remote connections that anybody would use. For SSH, it's a secure remote connection with many different types of encryption that you can use. It passes code with security checks, public and private keys typically, and simply all your data is encrypted, and so it doesn't pass things through plain text like Telnet would. And it's very useful for remote connections that require a secure connection, such as CCAST or computational connections that would be needed for supercomputers. Next slide. So for Telnet, here is the main command. It's simply telnet, the IP address you're using. You can also put port number in there, but this doesn't work with domain names, and even if you have DNS enabled for your networking, you will not be able to be using domain names for your telnet. So you need to use IP addresses, and the problem with that is that connecting via an IP address is somewhat not very secure, and also using telnet in general isn't very secure. And so, like I said, this will likely not be used in the course, but it is good to know in case, your SSH is failing. So simply doesn't really work for devices that haven't been set up for SSH at least. Okay, so you can continue. Oh, next slide. There we go. So SSH works for IP addresses with port numbers and domain names. However, it requires setup on the device's end that you're going to be connecting to. CCAST is already set up SSH and everything like that, but for things like routers or something where it hasn't set up SSH yet, you may need to use Telnet. But SSH is a lot more secure, and it is what we use for computational work. And the syntax is SSH followed by whatever extra subcommand you would like to put in, which is like a -L or a -I or a $Y, which is what we used for this course. The $Y stands for a different security type. I believe it's X11 or X12. I forget exactly. And then it's followed by your user at the host name. So just like in the picture there, we show SSH -Y, the username at photon.chem.ndsu.nodac.edu, which is your host name. All right, next slide. So now we move on to opening an account on CCAST. Next slide. So here's where you start. You start by going to the main CCAST website for NDSU. You want to look for account application and remote access in the left tab bar, and click on both, open in new tabs. Next slide. Next slide. There we go. Okay. So for account creation, we start by clicking apply under the text of the intermediate page, which is directly at the top. You see their account application if you're NDSU faculty, etc. You simply click the apply link there, and it will take you to a Quora survey. And once you fill out that Quora survey, once you fill in the form, you just submit it. Go to the next page, or go to the next slide. And you will fill out the next page of the Quora survey. And once you have that Quora survey done, all you do is submit. It will take possibly a couple days, possibly a week, possibly just one day, maybe even a couple of hours if you're lucky. But typically it takes a little while to process. So give it some time, and then go to the next slide, please. And once your account has created, you will get an email confirmation from a CCAST administrator, and it will tell you how to SSH in, or what the host name is, and what your ID is. And essentially, that is the full part of CCAST updating. Go to the next slide. And if you need remote access, sometimes you may be in a different state or a different place, and you would have to sign up for remote access. So I have not done this because I live here in North Dakota, and I don't have to worry so much about remote connection access. But if you travel quite frequently, it would be good to get a remote access application, and as such, simply apply for remote access after finding the tab on the home page. And this is very similar to the account set up for CCAST. All you do is apply for remote access, then go through the form, and you should get an email confirmation after everything's been confirmed. All right, next slide. So now on to job submissions. Next slide. So how to submit a job into CCAST. So let's say you were doing a molecular computation, particularly an optimization computation, and we were using something like cinnamaldehyde. All you need to do is transport the molecular geometry out by a .com file, or if you can't, simply turn it into an XYZ or a PDB file. Then use the BABEL command that is used in the CCAST servers, and turn the .pdb or whatever file type you're using into a .com file. And once you've done that, you may need to use FTP if it was outside of CCAST servers, or you can convert it by other means and then transfer via a file transfer service or file transfer protocol software. Such as WinSCP, which you can see on the bottom part. And you can transfer the file to the server from that. Next slide. So how to submit a job. Firstly, you need to edit the file for the specific job needed. So if you just convert it to a .com file, you'll see what's on the right here. You'll see the coordinates and everything like that. You will see that the multiplicity is a little bit screwed up. And so you must change certain parts of the file to ensure that it works properly with the job submission service that we use, such as adding the %mem, 40 gigabytes, % lender workers, etc. up at the top there, and making sure you specify exactly what type of method that you'll be using for the optimization or the transition state, computations that you may need. All right, go to next. And for job submissions specifically, we use qsub commands for interactive jobs, which are most of the jobs that I would use. For instance, you will have to type in this exact sort of syntax, which is qsub -i -l, nodes, the number of nodes, ppn, the number of processors per node that you'll be using, -q, which will be the route queue name, and -l wall time. And that wall time is particularly very critical, as if you put it for too long of time, you can end up taking a lot of computational space where a lot of other computational chemists will need to use it. So make sure that your wall times are somewhat decently accurate and not, 4 hours for an optimization that's fairly small. So then you'll follow it by the file name. And for a batch job, a very simple batch job, typically you have to edit the file in the way that I had specified earlier, to ensure that the batch file actually optimizes everything. So make sure you do that before you do a batch or a regular Q sub, though you can use either depending on whatever you would need. And for when your computation's done, you will use that same file transfer service I had talked about, whether it be WinSCP or you can use MobaXterm. To transfer your files from the supercomputing node to either a folder in the supercomputer, or you can use it to transfer it directly to your computer for analysis. So wherever you would analyze your files, that's where you'd put it. Alrighty, change slide. Alrighty, this was already done, so we can skip the rest of this part, and that'll be my presentation completed.
Okay, please join me in thanking Jenise. And the presentation is open for discussion and for questions. Since those are practical skills that we all will do sooner or later in the course, please consider it as instruction, and if something is not clear, feel free to ask the speaker. Okay, let me start then. And if you're not sure, or oh, Kristen is here. Kristen, welcome to join the meeting. So feel free also to type question if you are not sure if your mic is working, or if we are short in time. So Jenise, you used the word node. What is node, and how many nodes are on CCAST?
So it does depend on the part of CCAST that you're on. I don't know specifically off the top of my head the amount of nodes that it has, but nodes are processing units where you can place in computational jobs, and you have a specific amount of processors in each node. So these processors, you can use a differing amount depending on which node you're using. And essentially, all these nodes are used for computational jobs, and once you move a job into a node, it will process, and once you're done using that node, it will spit out the job, and you can, actively use whatever you want with it.
Yeah, thank you. I'm going to ask a very quite silly question. I apologize for asking it, but it's better if just for everyone is on the same page. So why we need a cluster at all? Why we cannot run jobs on a local computer or on a simple server?
Okay, yep. So a normal computer does not have the computational power in certain cases. For instance, when you're doing multi-molecular files, it can be quite intensive on hardware. And for hardware for basic desktops, they simply do not have the power to do these computational jobs in a lot of cases. And it would take numerous hours, if not days, and will likely end up in your hardware failing or your job failing. And so we need use of a supercomputer because the supercomputer can actively do these jobs a lot faster and a lot more efficiently than a regular desktop computer. Although desktop computers are powerful, as of right now, supercomputers are quite a bit more powerful and have quite a bit of more computational use than regular desktop computers.
Okay, it is another chance to ask question to Janice. There is a typed comment from Levi Lystrom, who is a system administrator of Photon cluster. He suggests to use free nodes on CCAST. So more questions to Janice. More questions one. More questions two. More questions three. So there are no more questions. Yeah, there is also another comment from Mohammed Javad. I think the interactive node request syntax doesn't work in the new PBS system.
All
yeah,
right.
Thank you.
Do you happen to have resources on that specifically, just to make sure that my syntax is up to date on PBS systems and everything?
So, Javad, if you want to answer, yeah.
Okay.
Yep. You can reply to the email of to everyone who is invited to the meeting, or okay, very good, very good.
Okay, perfect. Yes.
So please join me thanking Janice for the presentation. Thank you, Joyanta, for assessment, and Levi Lystrom suggests to change the group list. Okay, so the next presentation is by Mahima Murali. Yeah. So on, if you have camera available, please switch it on.
Yes, it is available. I did it, but I don't know, it's not showing.
Okay, but please keep going. Your slides are up, and tell me when to flip the slides. Okay.
So, are we not doing the first one, building atomic models? That presentation? It will be. Okay. So the outline for my presentation is modification of distances and modification of angles of particular chemical structures, modification of dihedral angles, and find out what are the differences after doing the modifications of these changes in a molecule. Next slide. So this is a particular structure. It has a distance, a particular modification done in this structure. So I will done it in next slides. Next slide. It's an animation slide, so you need to double click. Okay, so this is a CST structure. So you need to, so we are doing the, I think it got stuck in my, so we are doing the modifications of distances in this particular structures. So we need to select 2 atoms in the particular structure. So I selected 1 and 2. 2 is the center atom and 1 is the hydrogen bond, and this one is the carbon. 2 is the carbon. And next slide. I think my internet connection is not good. I cannot see.
So right now we are seeing modification of bond window. If you want to comment on this.
Okay, so you need to select this one, and there is a single bond, and you can change and you can modify bond types. So that is the first column, and that one is you can change single bond, double bond, triple bond, whatever bond you can. And for the next tab, that one is displacement. One atom's fixed and the other one is translate group, and translate and then translate atom, and then it's fixed. And the next column, the arrow mark showing, you can change those displacement, and you can change the distances, and then click the OK button. And the next slide, you will see the differences between the before and after the job completion.
So now we see, maybe it was jumped over the slide. Yeah, I think you want to show this one, before and after.
Yeah, before and after. So in this slides, so it is showing that the after and before changes happening in the modification of distances. And next slide. So you can see in that window, I selected the tab for the distances, and you will see the changes happened. And next slide, modification. I will talk about the modification of angle. So for modify angle, we need 3 atoms, 1, 2, and 3. So we'll select 3 atoms in the molecule, and you need to click on the angle tab, and you will see this tab is pop up, and you need to change the, you need to rotate the group and the atom and fixed, and you can change the, you can modify these angle for this particular molecule, and then click on, and you will get this clean modified version of this molecule. Lastly, these are all animation slides, that's why it's not popping in. So modification of dihedral angle, you need like 3. For this particular one, to select 3 atoms, and using displacement, you can change the displacement atom 1 and atom 4. And you can modify how much dihedral angle you want, and then click on OK. You will get the finalized product of this molecule. And we'll find the application of dihedral that in my last slide.
Okay, please join me in thanking Mahima. So
my work is not
no, it's very relevant, very relevant. Thank you. So other questions to Mahima? It seems quite instructive and very clear. No questions on my side. Any questions from attendees? If you can either speak out question or type it in the chat line. questions 1, questions 2, questions 3. Okay, there are no more questions because it was very clear. Please join me in thanking Mahima once again. So now let me invite to the stage JoyantaBanerjee. So he will explain what to do if the model is already made by hand, by human, and how to make some optimization steps. Okay, Joyanta, floor is yours.
Yeah, Dimitri, thanks. I'll be talking about cleaning and optimization geometry in gaussview. My presentation will be very short. And please, next slide. Actually, I have proposed here one molecular structure, like original structure of pyridine 4-carboxamide from corrupted structure to original structure. How to use cleaning tool that shown upside that you can open in Gauss view, and like you can draw a corrupted molecule like that is not properly optimized, and just you can draw by your mouse and put all those angles like not very proper, and your bond length that is not properly situated. So through cleaning tool you can clean it properly, and you can optimize the structure very properly from using the cleaning tool that I have shown upside. You can do it through Gauss view. That upside that is shown here, like you can do it in by click the mouse. This is complete. This is a structure of pyridine 4-carboxamide. This is not a proper structure. So using cleaning tool, you can easily change it the proper structure, like a resonance structure, and the bond angles and the bond length that should be proper. That you can do it with use of cleaning tool. Next slide, please. And then select the optimization job type, and then press submit. You have to first open it, and then in job type you have to do optimization, and then optimization to a minimum, and then whatever required things you have to put there. And then suppose the calculated force constants, you can use RFO step or like other things like that. And then through optimization you can get the proper the molecular structure, and that could be you can get it very proper way through Gauss view. Next slide. And then you will get proper structure if you run it with Gaussian. This is the proper structure. Thanks.
Okay, please join me in thanking Joyanta for informative presentation. So other questions to Joyanta? Feel free to please ask or type in the chat line. I do have one practical question.
Okay.
So if I need an oligomer or polymer, so if I need a repeating unit to be reproduced, do I need to draw it again and again in my structure, or there is a way to reproduce repeating units in Gauss view?
Yeah. So I think in my view, you can just copy and paste it like to chain, and like you can put it like n, and then put the numbers like n is equal to 2 or 3 or maybe 4. Then I think you can get the proper structure. like CH2 third whole 4 or maybe CH2 third whole 5, and then so on and so forth, then you can the structure will be optimized through it.
Okay. Yeah. Thank you. Let's check if there are more questions. More questions 1, more questions 2, more questions 3. If not, let's thank Joyanta once again. Thank you for presenting. And now we are moving to presentation number 4 by Dr. Zheng, and it will be a very important and interesting presentation. It is on how to build structure without building a structure. So it's the importing the important. Sorry. Just a second. Oh, better. So it is a very important skill for computational chemistry. So if you have a camera, you are welcome to enable it, and floor is from the beginning. Yes, floor is yours.
I'm in lab, so I don't think I can use a camera.
Okay, that's fine. That's fine. Let's go without camera.
So the file uploads and downloads directories. Next slide.
Mm-hmm.
So these are the common Linux commands. PWD means shows the pathway of the directory, and ls lists all the files and directories in the current directory. CD is changing directory. mkdir is make new directory. As you can see, when we type mkdir presentation, then tab list, we can see the presentation is in the current directory. And vi is text editor. More, use more command, you can view the text in the files. To copy file, we use cp command. After we type cp test and test2, the content of the test file is copied to the test2 files. rm is used to remove files. Next slide. So we use this to download files from a server. The scp command is used. As you can see, when we type, as you can see, the test file in the server is downloaded to my local computer after we type this scp command. Next slide. So to upload the files, we also use scp command. Here shows that the CIF files is uploaded to the server. So next slide. Build atomic models through Avogadro. Next slide. So by clicking the element label, we can change the elements. Here we choose carbon atom. Next slide. So by click the bond order, we can modify the bonds, single, double, or triplet. Next slide. By clicking the E label, we can optimize our structure with the UFF. Next slide. click the ruler label and then select item 1 and item 2. We can measure the distance between these two items, namely their bond length. Okay, next slide. The atomic models from X-ray diffraction data. Next slide. So we can go to this website to build crystal unit. As you can see, we can put the required elements in your molecule in the position of the red circle. Next slide. And then we click the COD ID and download the CIF file. Next slide. So we can view the CIF file with a head or tail command in Linux. It's just some text. But we can open the structure with VESTA software. Next slide. So as you can see, the structure of this molecule in the CIF file can be seen with the VESTA software. By clicking object, next slide, sorry. So by clicking the objects and then boundary, we can extend the structure from one unit to whatever unit you want. Yeah, next slide, sorry, yeah. So here we choose, we extend the structure to 3 units, and we tap the 3 in the X and Y, Z position, and click apply. Next slide. Here is the results. Next slide. So by clicking edit and bundles, we can adjust the bond length. So we can tap the numbers in the max length position and then click apply. Next slide. So here, the left figure shows the results when we input the length 3, and the right figures tells us the results when we input the length at 8. So we need to adjust the bond length to get reasonable results. And next slide. Do I have next slide? Oh, sorry. So to save the files, we click the file and then export data, save it as PDB or XYZ files. That's it.
Okay, yeah, please join me in thanking you, Zheng, for a nice presentation. And other questions to the presenter, to the speaker. So, in which situations one needs to use database? When to decide if I want to build model or import it from the database?
When we have a periodic unit in the molecules, we won't just use a database to build the one unit and then extend to whatever units you want.
Okay, yes, very good, very good. More questions to the speaker? If no, let's thank you, Zheng, once again. And we are doing really good with the schedule today. So let me suggest to go to the last but not least presentation of today's session by Kristen Patnode, and she will cover the subject of what to do in case connection to remote servers is a little delayed and one needs to build, optimize, and analyze pre-made models with facilities available local computer. So Kristen, please, floor is yours, and if you want, you can enable camera.
I'll have you start by going to the next slide. So here I just have an outline of what we'll talk about, as Dr. Killen already mentioned. First, we'll look at JMOL, using JMOL to both build models and then save files that are able to be exported into either gaussview or any other software. And we'll look at Avogadro, which you already mentioned a little bit about, but continuing how to build models and optimize them, and then again, how to save or export them in a format that is usable. And then lastly, I'll look at the BABEL command in converting files, how to use and operate that command within terminal or mobile Xterm, and I've provided an example there as well. So the next slide. So JMOL, just as a kind of background, is an open source and Java-based program that is used to visualize atoms and their molecules. In order to open a file in JMOL, first you can download JMOL for free to your own personal PC, simply by Googling their website, and then the download is a zip file. And so I know it's not compatible with all personal computers, but at least with Mac, it's pretty functional to download the zip file. And then as long as you place it to whichever folder you use, typically for your terminal or mobile Xterm, you're able to easily work within your terminal command to reach JMOL. So the next slide is, if you're starting from your command prompt, how to open JMOL is that bottom part in red. It's essentially the command that starts with the squiggly line. And then I have a file name, which would be to open a specific file. But if you don't have a file name, it just opens the entire application that is JMOL. So it open a blank JMOL where you can start fresh and build a brand new model. Then the next slide. So building models in JMOL is pretty straightforward. It has a build button, and then you choose whether or not you are going to be building additional carbons, which element you want to choose. If you go to the 3 dots at the very bottom, it pulls up a periodic table, and you can choose whichever element to be working with. You're also able to change bonds to single, double, or triple bonds, as well as move those and change length and position of each bond. If we go to the next slide. Oh, I thought I had an export. There it is. So to save files out of JMOL, I have 2 images there. The image on the left is how you would save a file just within JMOL itself. And that's by going to export and then write state. But if you want to export it and be able to use it elsewhere, you'll go down to that Gaussian option, and then you're able to choose or save the file as a .com file. And that way you're able to open it in gaussview much more easily. So then we'll go to the next slide and start talking about Avogadro. Avogadro is another open source molecule editor. This one's actually designed specifically for cross-platform use in computational chemistry, molecular modeling, and material science. Again, it's a free download. I believe this one's a DPP file. I forget the name of it, but also may not be compatible with all personal laptops, but certainly with a desktop computer, sorry. We go to the next slide. And building an Avogadro, which you already touched on, is pretty straightforward again. Similar to JMOL, you're able to choose whichever element you want to be working with, and then draw and connect your bonds as necessary. I personally find Avogadro to be much more user-friendly, and then it's a lot easier to edit as you go. And so here I just do an example. This is, I don't have a name for it, but just an example of something I was drawing, messing around with, and going forward, I'll end up showing an optimization of this if we go to the next slide. So in Avogadro, which is a benefit as compared to JMOL, you are able to optimize using a number of different force fields. I do have a few animations here, Dr. Killen, if you wouldn't mind clicking. Yeah. So first, to get to your optimization, you click the capital letter E, and then that takes you to kind of this panel on the left that has force field, steps for update, the algorithm, and a few other options down there. If I can have you click twice more, Dr. Killen.
Okay.
So first, there's the force field. By default, Avogadro will use universal force field, but it also has a couple of other options, including GAF, MMFF94, MMFF94S, and Gemlicool. I believe are the other ones it has. And so depending on what's best for your particular model, you can adjust that. For most scenarios that I've encountered, UFF works the best. Then if you want to change steps for update, you're welcome to. Other options with the algorithm, it's start. The one thing about optimization in Avogadro is it doesn't stop on its own, so you do have to manually stop the optimization process. And as you can see on the right image, that's my optimized model from the previous slide. So then we can go to the next slide. Saving files from Avogadro is much like JMOL, pretty straightforward. There's a save as option in the top left corner of the application, and then you're able to choose in that drop-down bar of any type of format you would like to save in. I have highlighted PBB just because I find that most useful for my personal work, but there's also XYZ, GAM, CML, Gaussian. So a lot of different formats that you're able to save as directly from Avogadro, which makes it a little bit more compatible with certain other applications or programs. So the next slide, I think, wraps up Avogadro. Yeah, so then I just kind of touched on, I use Avogadro nearly daily in my own research. I find it extremely user-friendly. Having the option to save in different formats is super helpful and makes it a lot more cross-compatible. It also offers the optimization, which is quick and sufficient for a lot of uses. Oh, it does, Levi. Thank you for adding that. I didn't know that. So then I think that wraps up Avogadro. If we go to the next slide. Oh, I just showed an example of why I use Avogadro because it's so user-friendly. This is an example of one monomeric unit of the polymer that I'm working with. And so to draw this on JMOL is extremely tedious, whereas using Avogadro is a lot more doable. But we can go to the next slide. And then I just conclude here with converting formats using the BABEL command. BABEL is a translating tool which allows for easy conversion between format types. Examples being converting from an XYZ file to a PDB file, to a MOL file to a CDX, HIN to Gaussian, or any combination of those. So there's a whole list of all the different formats that BABEL converts between that you can look at through your terminal. But if you go to the next slide, I think I have just an example of using the BABEL command. Yeah, and so the input that you would have for the BABEL command starts with -I, and that I stands for input, and then you put your file name in the original file format, and then -O, which is designating the output. You'll type the file name again with your desired format at the end. And so in red, again, I have box, an example of that command. And that just converts your file right to terminal. And I think that I might have one more slide, but otherwise that is a summary. So yeah, as a summary, both JMOL and Avogadro are free open source modeling programs. I find Avogadro to be more user-friendly, but it does cause some more difficulties working with gaussview, whereas JMOL works a little bit more hand-in-hand with gaussview. JMOL does not have the optimization feature that Avogadro does, so that does create a two-step process for optimization. And then BABEL is a conversion command that you can use within Mobile Xterm or Terminal to convert file formats.
Okay, please join me in thanking Kristen for interesting and informative presentation. And the presentation is open for discussion and questions. So if anyone, there is a, yeah, yes.
So I just had a comment on energy optimization with Avogadro. There is another way to optimize energy that is a little bit more specific, specifically going to the extensions tab, and then going to set up force field, setting up the force field, and then clicking optimize geometry in the extensions tab as well. And that one is a little bit more specific and stops it as soon as it hits a step count.
Thank you, Janice. Okay. I think we are moving towards typed interactions more and more. I do have a question, not about your presentation, but more about applying your skills to research. So which strategy would you use if you need to create biopolymers? For example, if you need to build a single or double strand of DNA with a specific sequence surrounded by water box, like which software would you use, or which databases would you look through? How would you approach this challenge?
I would first, if it's a DNA sequence, hopefully you'll be able to find the protein using a protein data bank. So rcsp.org, and then you can use that PDB file and incorporate it into either Avogadro, or I also use HyperChem, where you can then insert the solvent box, or sometimes using Autodoc would work to incorporate your solvent box, where you choose water or whatever your solvent would be.
Okay. Yeah, thank you. And I do have just a little personal curiosity about your molecule that you did show in your slide 11. So is it hydrophobic or hydrophilic with hydrogen? Like, is it soluble? Is it soluble in water?
Yes. So that is actually a emulsion polymerized latex that is soluble in water, but it is hydrophobic.
Okay.
It stems from a hyalix soybean oil, so it's rather hydrophobic due to the oil content.
Okay. Yeah. Thank you. Just Levi requested to show the slide once again. Yes. Here. This one. Okay. So, are there more questions to Kristen? If no, questions 1, questions 2, questions 3. I think there are no more questions. I thank Kristen once again. And so I'm going to show the slide with the list of presentations. So many thanks to all participants of the class. It was very informative talks which covered vital and practical skills that we will be using in the rest of the class. These successful presentations are considered complete. From now on, all class attendees are certified experts in building molecular models and getting credit equivalent to 3 successful homeworks. So let me thank class attendees and all guests and visitors to the session with a round of applause. And with this, I would like to close the formal part of the class. So we are done. Everyone is okay to disconnect, and I'll stay in the connection just in case there are some additional questions or brief discussion points. So many thanks to all participants, and this session is done. Let's meet each other for the class attendees on Monday 5 p.m. to start new chapter on electronic structure and chapter on Hartree-Fock theory. Done. Oh. Let's see who is connected. Levi, I see your... yes, but then it will be a lot of mess to for file transferring. I think, and we will soon move to personal accounts, but let's use what they use right now if there are no difficulties from your side. And thank you for, okay. Yeah, good. Thank you much for helping to Banerjee, Joyanta. It's really, I think it is your and Jabet's credit, because he started later and he was not comfortable of presenting today, so you did save the situation. I appreciate help of Levi and Jabet. So I think it's only Levi and myself who are connected. Levi, do we need to discuss anything else? If no, then no, I just was asking about the account. Have a good day. Have a good day, you too. Oh, how did your interview went? How long was it? How enthusiastic other side was, if I may ask? I'm just curious. Okay, yeah, nice to hear. Well, I wish it converts as soon as possible into solid written offer. And the job is a little different than I thought it would be. But it will use your skills and background. Will help. He said they would let me know sometime next week. Okay, very good, very good. Did they ask? Do they have specific project they want you to work on, or they want you to write a mini proposal? Like in my time when I was a closer to us, I would want to compare to what I was thinking. Okay, good. When I was in my time applying to several postdoc jobs, some of the positions require like little independence when candidate writes what he or she wants to do. They didn't ask. Okay. Yeah. Well, many thanks for sharing news. Many thanks for sharing news. With your permission, I'm going to. I think I would write it on the work with Dr. Sibi and Zhao. Okay, yeah. Okay, bye.